So what is an overlay tunnel and how can we understand this topic? This is where I'm going to tell you. This part is divided by four parts: generic routing, encapsulation, IPsec, Cisco, LISP, which is the another way to another name for SD-WAN, and VXLAN. Now, what is this what is the meaning of GRE? Now, this is the basic and the foundation of the VPN, which is called tunnel. This is the main, this is the main foundation for protocols. Tunnel is being created even. Now, what is the word for generic meaning? Now, the word generic means not specific to one protocol or one use case. It is not tied to one, it is not tied to anything. All your data is encapsulated. That means it's like a tablet. You see a tablet, medicine tablet. A tablet, within that, anything, the elements that you have in that tablet is what it contains. So it encapsulates. That's where the word comes from. So when we say GRE works over IP are just IP packets, they rely on the existing routing table, the GRE. So you have the physical part, which is your normal IP addresses. In that IP address, there will be another IP address that's gonna bypass everything, that will go through your firewall and everything through that IP. So you will listen to more words like header and payload. Now, what do they mean? A header is information added to the data that tells where the network what to do with it, where it's going. So it's a routing protocol. And then you have the payload, that data, it's called the payload. So what does GRE do? What does GRE do? GRE adds new header and and that header gives new instruction. The old packet becomes the payload. The packet becomes the data inside the. So another layer of informations are added to the original packets. So that's the main foundation of the GRE. And then this is how it looks like. Original packet data, GRE flags. So it adds a new header information known as capsule to the packet. The new header contains the remote endpoint IP address. So that header will have the IP address, will have the information to reach your destination. Until it's reached to the destination, it wouldn't unwrap the information yet. So that's why it's called encapsulation. Then the new hyper ID enables to be routed between the two nodes without the inspection. Okay, without when the packet reaches the other, the GRE are removed, known as the and the XF out of the order. Now then, this is the basic diagram we'll have. The This is where we'll R1 wants to go to the R2 G01. So they have the tunnel, the IP address for the tunnel will be 192.168.100. The already routed so when I told earlier, this will be, we learned about the payload, right? We learned about the payload and the header. Now this IP address is the new header, and all the information which is 100.64 will be the payload. This is the how to configure the GRE tunnel configuration. Or I mark the step 1 and step 2 and step 4, like how it goes. So we have the GRE tunnel. Okay, so don't worry about this one. I mentioned it down. Underlay network and the overlay network. Overlay network, this is the GRE, which is the payload, the header, and this is the payload. Now earlier you saw the destination, right? This part of the destination. This is what it means when the packet the info to bear between them without the new this node contains the remote endpoint, and that is this one. So when it reaches to the endpoint, it will be de-encapsulated. And then we have the router OSPF that contains the network, of the for the overlay. So this is how it will. Keep this in mind, huh? Router OSPF and the routing protocol and the GRE part. This is the GRE, which is called generic routing indicator, which is the another name for tunnel. Now next is this. What is the GRE? The optional method one. Look at this one. Why MTU exists? Network cannot exist. Infinite size packet. Every link has a size limit. It must be slid or dropped. So standard Ethernet, jumbo frame, data centers. Why and DRE at extra? So original packet plus outer data frame must fit under that. So it's more like the size of the how to install it. Now then, this is the example. Configure R1 following the steps listed. So click on this and to watch it. Now how to verify the GRE tunnel. Show interface tunnel. Keep don't do the keep alive. This is your underlay network destination. Another important command, show IP route and trace route. The part where you will see the tunnel 100, and you will need to problems with overlay network. Now what does recursive routing even mean? The recursive in short, it means that uh, you see this. Do you see this part? This is bad actually. Your the network for your tunnel is being leaked onto the router OSPF database. So router OSPF1 has the route map saying what is the tunnel. It's like exposing your information. So you even see in the even this one, see, it shows your information. Now this is actually bad. Why it says it's bad? Because it says, oh, you have the tunnel. Now this is where the recursive part comes in. What does recursive? You need to separate this part. For the learning experience, yeah, you can add to the OSPF, but for the learning, for the implementation, you need to work on it. And this is where it says prevent from being advertised across the tunnel network. Do not let routing protocols inside the tunnel advertise, learn, or prefer routes. Keep those endpoint IPs, learn to static routes. This slide is describing a design problem in GRE underlay network, the real physical. The problem when the routing frame for tunnel gets advertised in the overlay routing area. So this is where VRF comes. Also on board the physical network and gets advertised. Now the problems that comes with the leakage of the network. This is to build the business. And I want to show you guys the VRF part. So why the mention of VRF? VRF, it's like it will separate your the part for it is the solution for this recursive, and this is the example. We don't need this. Now this is the main part. Okay, we don't need this. This is the LAN network, but this is the main important one. Okay, now you have this. Now this is the R2 router 2 tunnel source. And did you the payload, this is where it shows that that definition for the payload. See, this is the header. The header is the overlay network, and the payload is there that it's wrapped now, and this is what it means. So